Welcome to the class 12 students. Students, this is DEEPAK AWASTHI and JVS. Today, I am going to discuss the chapter 3 of your NCERT book, that is electricity. In that, as subtopic is their electric current and resistance. Students, like and subscribe our channel and also press the bell icon for getting the further notifications. Now let us start the chapter. Here students, the name of the topic is electric current and resistance. So first of all, I will explain electric current and thereafter I will explain resistance. So before starting electric current, I want to discuss a few more important concepts for the better understanding of the electric current. Here students, I have mentioned that electric current flows always from higher potential to lower potential. So this thing you will have to keep in your mind. Students, all type of current, not only electric current, all type of current always flow from higher potential to lower potential. Current can be many types. In case of river current, river always flows from mountains to the ocean because mountain has the higher potential and ocean has the lower potential. So the river current flows from higher potential to lower potential. In the same way, electric current always flow from higher potential to lower potential. Students, for elaborating this thing, I have mentioned here two spheres A and B. In A, 5 volt potential is there. In case of B, 10 volt potential is there. So B is at the higher potential and A has lower potential than that of B. So electric current will flow from B to A. Consequently, the electrons will flow from A to B if we connect them with a wire. As students, you have been taught in class 10 the definition of electric current, that the flow of charge per unit time is called electric current. That you have been taught in class 10. But in case of class 10, you have been taught whenever the electron flows, then only current flows. Here I want to tell you that the motion of the charge is the consequence of the creation of electric current. So charge may be electrons or ions. So this thing depends on case by case. So here, for elaborating this thing, I have mentioned 3 points. First point, in case of conductor, free electrons are the responsible for the flow of charge. That is, electrons are the charge carriers. Due to the flow of electrons, the current passes through the conductor. In case of liquid, ions are responsible for the flow of charge. That is, ions are charge carriers. So in case of liquid, the electric current will flow through the ions. And in case of gases, ions are also responsible in case of gases. So here I have mentioned, in gases, ions, positive or negative, are the responsible for the flow of charge. That is, ions are charge carriers. So whenever students, charge will flow, the current will produce. Okay. So here students, I have mentioned electric current is a scalar quantity. Now one question is there, this question. Electric current has direction, that is higher potential to lower potential, and it has magnitude. It is still a scalar quantity. Why? This is the question, and the answer of this question you will have to give in the comment section. Now students, type of electric current. So students, electric current is of three types. First one is the steady current, number two is varying current, and number three is alternating current. So what is the steady current? When the magnitude of current does not changes with time is called a steady current. Here students, I have made a graph. I have taken time along the x-axis and I have taken the electric current along the y-axis. So here the amount of current is fixed. That is the reason time is passing and an amount of current is fixed. That is the reason the graph is the straight parallel line to the time axis. So whenever the current will not change with the passage of time, then the current is said to be the steady current. Suppose in case of wire, if I made a strategy to flow the electric current through the wire by a constant amount and it is not changing, then the current flowing through the wire is said to be a steady current. Now come to the point, varying current. So here students, I have mentioned when the magnitude of current changes with time is called a varying current. Suppose students, there is a wire and current is flowing through it and it is varying with time. As the time passes, the current goes on up and down, or up and up, or down and down in irregular manner. If current is varying as the passes of time, then the current is said to be varying current. Now very important thing is here, alternating current. An alternating current is one whose magnitude changes continuously with time and direction changes periodically. Students, alternating current is a type of current that changes its direction after a regular interval of time or after a fixed interval of time. Suppose in a wire, current is flowing and it is changing its value after a definite interval of time, then the current is said to be alternating current. Now let us discuss the electric current in a metallic conductor. Students, here for the understanding this concept, first of all let me explain that this is the conductor. I am going to draw it over here. This is the section of a wire and we have attached it through a battery. This is the battery that I am making here. So this is the positive terminal of the battery and this is the negative terminal of the battery, and there would be many free electrons in this. Students, I am focusing on one electron. So if the current is flowing through this conductor from positive terminal to lower potential, from positive terminal to negative terminal, what do I mean to say? From higher potential to lower potential. So here students, I have mentioned every material made up of atoms, and atoms are made up of electrons, proton, neutron. In case of metallic conductor, electrons in outermost cell of atom gets free from atom by using thermal energy at the room temperature and becomes free to move in the entire volume of the conductor, just like an ideal gas in the container. So in conductor, free electrons moves in the entire volume of the conductor. Students, the electrons are free from the atom by getting the thermal energy from the surrounding. What do I mean to say? Let me explain it. Suppose a wire is kept anywhere, it is kept open, then and current passing through it, the wire will get heat up. No, this will not be good. Students, let us discuss electric current in a metallic conductor. So before starting this topic, I want to ask a question. Students, have you ever thought why the electric current passes through a conductors? I mean to say, why the electric current passes through metals? Why not through wood, rubber? What is the special thing in case of conductors, in case of metals? To know the answer of this question, let us move inside the conductor. Let us move inside the wire. Students, you know, every material made up of atoms, and atoms are made up of electron, proton, neutron. In case of metallic conductor, electron in outermost cell of atom gets free from atom by using thermal energy at the room temperature and becomes free to move in entire volume of conductor, just like an ideal gas. Students, you have been taught in class 11 kinetic theory of gases. In that, an ideal gas was kept in a container, and the molecules of the containers do a random motion inside the container. In the same way, electrons also do the random motion inside the conductor. For the better understanding this concept, let us draw a section of wire. Students, this is a section of a wire. Let me draw it. This. And just like molecules of the gas, electrons are inside the conductors. These are the electrons. These are many electrons are there inside the conductors. Many free electrons are there. These are, and they will perform random motion. So for discussing it more clearly, let us focus on one electron. Suppose this is the electron, and the direction of this electron is this. So it will collide with another electron, then it will change its path, then again it will collide, then again it will change its path, and so on, in this way. Students, see here, relaxation time. In case of free electrons, the time taken between two successive collisions is called relaxation time. This is the electron, and when it will collide with another electron, then the time taken between first and second collision is called a relaxation time. Here, students, I have mentioned tau 1 as the first relaxation time in first collision. After this time, tau 2 is the time taken in the second collision, and tau 3 is the time taken in the third collision, and tau 4 is the time taken in the fourth collision, and so on. So I have added all the time and divided with the number of collisions. Then we will get average time. So this average time is called exactly a relaxation time. So in this way we can say that the time taken between two successive collisions is called a relaxation time. For better understanding this concept, let us take a ball. As students, in your childhood, you have purchased a ball which have a very much elasticity. When you strike this ball through the walls of your room, then it will keep on colliding with this wall, with that wall. In the same way, many collisions it made due to high elasticity. In the same way, electron do in a conductor. Now students, mean free path. So students, average path traveled by a particle between successive collision is called mean free path. Here particle is an electron. Students, we had focused on a electron. It was performing random motion. So first, whenever it is going to collide with another electron, it will travel a path before first collision, and after second collision it will also travel a path, and the same way also before the third collision. So these paths are lambda 1, lambda 2, lambda 3, and so on. So suppose electron have traveled in n paths. So the average of those paths is called mean free path. I mean to say, mean of the paths is called mean free path. Here, average velocity with which electrons move in a conductor in a random direction is 0. Students, suppose an electron inside a conductor. This is the electron and this is the conductor. So let me draw it. This is the conductor. This one is the conductor. First it has gone there, and here it has collided with an electron. Then it again changed its path. So in this direction, so in this direction, in this direction, in this direction. Too many directions were there. So too many velocities were there, and these velocities will cancel each other because due to the change in the direction of the electron. So the average velocity of the electron inside a conductor is 0. Individual velocity of a particular electron in a different collisions have the different directions, so they will cancel one another. This thing I have actually mentioned here. Here students, drift velocity. What do I mean by drift? Drift means होता है धक्का देना. So let us elaborate this thing. Students, this is the conductor. This one is the conductor. Let me draw it first. This is the conductor, and there were many free electrons inside this conductor that I have drawn before, and we have connected this section of a conductor through a battery. This one is the battery. So this is the positive terminal of the battery and this is the negative terminal of the battery. Students, whenever we will attach it through a battery, an electric field will establish inside the conductor, and the direction of electric field will be positive to negative. This will be the direction of electric field inside the conductor. So due to this electric field, electron will feel a force towards this direction, opposite to the direction of electric field. So when potential is applied across the end of the conductor, electrons get drifted due to the potential difference. Whatever velocity they acquire during drift is called drift velocity. Students, electric field will establish and potential difference will also create, because the length of this conductor is L. So there will be a potential difference between two terminals of this conductor. So due to the potential difference or due to the electric field, they will feel a drift force, a force they will feel, due to which they will drift towards the positive terminal of the battery. So by which velocity they will drift, that velocity we will call drift velocity. Now students, we are going to establish a relation between electric field and drift velocity. Here you see, let a metallic conductor connected to a battery that I have connected already. L is the length of the conductor that I have pre-assumed. N is the number of free electrons per unit volume. Students, here I want to explain it. N, small n, is the number of free electrons per unit volume. What do I mean to say? Suppose n electrons were there, n free electrons were there inside the conductor, and the volume of the conductor is what? Is V. So small n is nothing but n upon capital N upon V, means number of free electrons per unit volume. Okay, and V is the potential difference across the conductor. Due to the potential difference, a field will set up in a conductor. Due to this, electron will experience a force. Obviously electrons will experience a force. So according to the electrostatic that you have been taught in chapter 1, the force will be F is equal to QE, where Q is the charge whatever electron have. So I have mentioned here small e that you have been taught in class 10. So the force will be F is equal to minus QE. Why the minus sign is over here? Because minus sign is over here indicates that the force will be the opposite direction of electric field. So what will be the force? F is equal to minus small e into capital E. And we know that from the Newton's law, F is equal to ma, mass into acceleration, that we know. This is the second law of Newton. So these two formulas will be same because the force is same. Ma is equal to minus small e into capital E. So what would be the acceleration? Acceleration would be A is equal to minus E capital E upon m. So the acceleration would be A is equal to minus small e upon capital E, sorry to say small e into capital E upon m. This is the acceleration due to the drift force. Now students, we know that this is the first equation of motion that you have been taught in class 9. V is equal to U plus AT. V is equal to U plus AT. Students, here V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time. So students, let us again focus on one electron. So this is the electron. Just after collision, it starts moving, and it will move till it again collide. So in between these 2 points, suppose here it has collide with this electron. So this distance, this is the lambda. In just a minute. This is lambda. This distance is lambda. So students, in between these 2 points, I am applying the first equation of motion. So Vd is the drift velocity, means final velocity, initial velocity after collision, and A is the acceleration and tau is the relaxation time. I mean to say time taken between 2 collisions. So here, students, I have taken full average. Average drift velocity is equal to average initial velocity plus acceleration into average time, average relaxation time. So average initial velocity that you have been taught is 0 because of the different directions. So Vd is equal to A tau. We know the value of A. A is what? Small e, capital E upon m into tau. We have put the value of A in this equation. The value of A that we have find out, this was E into capital E upon m. So this value we have kept in this equation. So we will get Vd is equal to minus small e into capital E upon m tau bar. So here I have taken a mod, so minus sign have been removed. So the drift velocity is Vd is equal to E tau small e into E tau upon m. Okay students, now the mobility. Mobility. What is mobility? We know this formula. Vd is equal to E tau upon m, E into capital E tau upon m. So students, mobility is nothing but a drift velocity per unit applied electric field. This is the mobility. So Vd upon E is equal to E tau upon m. This is the mobility, E tau upon m, where Vd upon E is called mobility, that is drift velocity per unit electric field. Now students, let us establish a relation between current and drift velocity. Students, consider a portion of copper wire through which current I is flowing. So for explaining this concept, let us draw a diagram. Students, this is the diagram of a conductor. Let me draw it. I will draw the same diagram as I have drawn earlier. This is the conductor. This is the section of a wire, or this is the portion of a wire, and we have connected it through a battery as I did earlier. So this is the positive terminal of the battery and this one is the negative terminal of the battery. And A, so here let A is the cross section of wire. So this area is A. This is called cross section area. This area, this is A, and N is the number electron density, that is number of electrons per unit volume that we have drawn earlier, and that was N is equal to capital N. This is the total number of electrons and V was the volume of the conductor. So here in this case also, let the number of electrons, total number of electrons are N and the volume of this conductor is capital V. So the electron density would be N. Okay. E is the charge on each electron. Vd is the drift velocity of free electron. Students, whether I say free electrons or electron, both are the same thing in case of conductor. So here students, L is the length of this conductor, A is the cross section area, and we have applied an electric field through it, and Vd is the drift velocity. Electric field E is established from positive terminal to negative terminal, and V is the potential difference across the end of this conductor. So electric current. See students, let us try to understand this concept very clearly. So here I have mentioned amount of charge passing through a cross section of a wire per unit time. Try to understand. Amount of charge passing through a amount of charge passing through a cross section of a wire per unit time. What it will be said, because I have mentioned here per unit time, that will be electric current. So see students, what is the amount of charge passing through a cross section in a unit time? See, n is the free electrons, means small is n is the number density, and v is the drift velocity. So suppose this is the electron and it will move towards this direction. So in 1 second it will travel a distance is equal to Vd. It will travel a distance, this distance, this much distance it will travel, that will be equal to its velocity Vd. Okay, this distance is Vd. So the volume will be what? Vd into A. A is the cross section area, Vd into A. So in that, how many electrons are there? Electron density was n. N into E will be amount of charge. N is the number of electron and E is the amount of charge. So the total charge will pass through in 1 second through this cross section will be NEAVD. So it is passing in 1 second. So that will be amount of electric current. See here students, I is equal to Q upon T. T I have mentioned 1 second unit time. Q was we have find out NEAVD. So NEAVD upon N is equal to NEAVD. So I is equal to NEAVD. So this is the relation between drift velocity and electric current. Students, we know that I is equal to NEAVD. So here students, what is Vd? That we have already find out. Vd was nothing but small e into capital E upon what? M. So this value I have kept here. So we have got NEA bracket, this is the value of Vd. So finally we have got NE square A E tau upon M. So students, we have sent A in the denominator of I. So I upon A is equal to NE square capital E tau upon M. So I upon A is nothing but a current density. I upon A, where J is current density. I upon A is called J. Current density is defined as the electric current per unit cross section area. Okay students, electric current per unit cross section area is called current density. So here students, sigma is equal to NE square tau upon M. This shows that conductivity. Sigma is the ratio of magnitude of current density to magnitude of applied electric field. Students, this quantity is called what? Is called conductivity. Students, in class 10 you have been taught resistivity. The reciprocal of resistivity is called conductivity. So this thing I will elaborate after some time, but for now this is conductivity. So J is equal to what? J is equal to sigma E, because the value of sigma is Ne square tau upon m. This sigma is called conductivity. So we can define the conductivity as the current density per unit electric field is called conductivity. This is the new definition of conductivity. So here, students, we can redefine electric current as it is the dot product of current density to cross section area. So here I is equal to sign of integration J dot dA. Students, sign of integration why I have mentioned. If you have understand, let me know in the comment section. If not, then I will explain. Now students, let us discuss the Ohm's law. So here the current I is flowing through a conductor. The current I is flowing through a conductor is directly proportional to the potential difference V across its end, provided the physical conditions, temperature strain do not change. I directly proportional to V, or V directly proportional to I. Students, let me elaborate it. See here is the section of a wire. I am drawing the same figure as I have drawn earlier. So this portion of the wire, I have connected it through a battery. So this is the positive terminal of the battery and this is the negative terminal of the battery. This is the positive terminal and this is the negative terminal of the battery. So students, and I amount of, and here students, we should take a variable battery. This battery is the variable battery. What do I mean to say? We can vary the potential difference of this battery. So students, let at a fixed value of potential difference, amount of I is flowing through it. As we increase the value of V, the value of I will increase. So here V is directly proportional to I. So for removing the sign of proportionality, we have to introduce a constant. So here I have introduced a constant, that is R. So V is equal to R into I. This is R into I. This is the Ohm's law. So students, let us take I along the x-axis and V along the y-axis, or vice versa if you want to take, because this is the problem of two variables. Students, if you will draw the graph of this equation, you will get a straight line. Let me explain. Let R is equal to 2 ohm. Let R is equal to 2 ohm. So you will get V is equal to 2I. Students, you will put the value of I accordingly, you will get the value of V. and now you draw the graph. You will get a straight line graph. This graph will be same as the graph of y is equal to 2x. Now students, let us discuss it more precisely. What is the validity of Ohm's law? Let us discuss it. Students, we know that I is equal to NEA VD. This thing is known to us. Now VD is also known to us. These things we have found out earlier. VD is equal to small e capital E tau upon m. So we will put the value of VD into this equation. So we will get V is equal to IML upon A E square n tau. So students, what we will get, see here, V is equal to I M L upon A E square n tau. Students, we know that V upon I, we will send I into the denominator of V. So what we will get, V upon I is equal to ML upon A E square n tau. This thing we will get. So V upon I is known to us, that is R is equal to ML upon E tau upon A E square n tau. So students, see here, M E square n tau into L upon A. So students, you have been taught in class 11 the formula R is equal to rho L upon A. Rho L upon A. So see here, this formula is same or not? Only we will have to keep the value of rho. This value of rho we will keep here. This formula will become same as this formula. So this value is what? This is the resistivity. M upon rho is equal to M upon what? N E square tau. This is the resistivity, and do the reciprocal of this quantity. You will get sigma. Sigma is equal to 1 upon rho. Put the value of rho over here. You will get sigma that we have found out earlier. So now students, we have got a formula R is equal to ML upon A E square n tau. This formula we have got. This formula we have find out. So here students, you are watching that R is directly proportional to L. I mean to say, when you will increase the length of the wire, then resistance will also increase, because the length of wire is directly proportional to the resistance. Here A is the cross sectional area of the wire. When you will increase the cross sectional area of the wire, then R will decrease, because A is reciprocal to R is reciprocal to A. See here, if the cross section of a wire is increased, then R reduce, because A is inversely proportional to R. Now students, M, mass of the electron, charge on electron, that is E, and number density. number of electrons per unit volume. These three quantities are constant. We can vary L, A and tau. Now students, let us discuss about tau. When tau will increase, then R will decrease. When tau will decrease, R will increase. Okay, because R is directly proportional to tau. Sorry to say, R is inversely proportional to tau. Students, when you will increase the temperature of the wire, then the time taken between two successive collisions will decrease. The velocity, initial velocity of the electron will increase, so the time taken between two collisions will decrease. When the time taken between two collisions will decrease, then what will happen? Resistance will also increase. Okay, when tau decrease, R increase. And when tau, how tau will decrease? When you will increase the temperature. So in this way we can say R is directly proportional to the temperature. When you will increase the temperature of the wire, then the resistance of the wire will also increase. And this is the formula. R is equal to R naught bracket 1 plus alpha T. Alpha is the coefficient of resistance. Students, alpha is the coefficient of resistance. Let me explain more about alpha. Alpha is nothing but a frictional change in resistance per unit change in temperature. See here, alpha is equal to R minus R naught upon R naught into T. Into T. Thank you students for watching this video. Thank you.